All right, boys and girls, so today we're going to continue our unit on multiplication. We're going to be focusing on single digit by double digit multiplication. One thing that will change your life is if everybody learns their multiplication facts. It will make things so much easier. There's no shortcut. There's no way around it. Going into fourth grade, there should be nobody drawing loops and groups for basic facts. You shouldn't have to do repeated addition anymore. Don't forget about those strategies. You need to understand how they work, but you do need to memorize them by now. Get some flashcards. If you don't have them memorized, make flashcards, practice them. Just work on like your sevens, work on your eights, work on the different factors at a time. Do what it takes. I'm telling you, it will change your life. So for today's lesson, we're going to talk about single digit by double digit. This is one way to set up this type of problem. We have the hundreds grids in a strip here. We took the small number, put it on the short side, and then 23, we have it stretched out across the top. This marker here is 10 units long. That represents one of the 10s from the 23. Then we have the second one that's 20, and then we have 3 individual ones, just like we have the individual 4s going down the side. So we're going to fill this in. This array is going to be completely full, and once we have done that, we will know what the answer to 4 times 23 is. It will be all the area that this is filled in. I additionally am going to do the same thing. I'm going to set it up with the area model that we've been working on, and you will see how these are basically the exact same thing. So when we do the area model, we have to decompose our double digit number, put it in expanded form. How many tens? There's 2 tens, so that's worth 20. And then there's a 3 in the ones place. So 23 is basically a 20 and a 3. So now we're set up for success. We're going to do both of them at the same time. And you will see how these are similar. Okay, so what I'm going to do is I'm going to fill in my tens first. So there's 4 23s. So I'm going to put the 20 from the first 23 here. 20 from the second 23 here. Here's the 20 from the third 23 and 20 from the fourth 23. We're not done yet. We still have to do our ones. 1, 2, 3. That's the 3 from the first 23. Here's the second 23 completed, the third 23 completed, and the fourth 23 complete. Now, if you notice, we have made 2 separate problems up here. We have one problem, the 4 times the 2 tens, which is exactly what we have here, 4 times 20. If I counted all these tens, 10, 20, 30, 40, 50, 60, 70, 80, and if we know 4 times 2 is 8 times the 10 is 80, we didn't even need to draw the base 10 block model. And then over here, there's a 3 across and then 4 down. 3 times 4 is 12. That's what we're doing down here. So if we find the sum of these products, the 80 and the 12, it ends up being 92. If I counted every single one of these squares on here, there's 92 filled in. So n, the missing value, n, is 92. So let's try another one of these. We're going to set it up here. This is 3 times 28, so that means we need to have 3 going down. 1, 2, 3. These are just my markers. These don't have any value. I'm going to write my 3 on this side. And I know that the big number, the double digit, goes across the top. So we're going to start with the tens. Here's 10. Here's 20. And then I need 8 of these bad boys. Maybe I'll just start figuring out how to clone this. Hold on. There's 5. course. Try to take a shortcut and it ends up being a long cut. 1, 2, 3, 4, 5, 6, 7. I need one more. Okay, there's my 28. I don't like my 8 here. It's supposed to look like a snowman. All right, 3 times 28. Now, like I said earlier, we're going to also show you the area model. We're going to see how they are the exact same thing. Let's decompose our 28, expanded form. 20 and 8. Now we will fill in our tens first of the 28. Oh, that was a really bad straight line. So there's 2. That's 20 from the first 28. Here's a 20 for the second 28. And here's a 20 for the third 28. So basically all this filled in, that's going to coincide with this right here. So 3 times 20, if I counted them, 10, 20, 30, 40, 50, 60. 3 times 20 is 60. And you just need to know 3 times 2 is 6 times the 10. And next, we have our ones. 1, 2, 3, 4, 5, 6, 7, 8. That's for the first 28. 2, 3, 4, 5, 6, 7, 8. That's the second one. And then the third and final, 5, 6, 7, 8. So if I added up all of these little squares, it would be 3 28 times or 28 3 times. So just to solve the blue portion, it's 3 times 8. So I'm going to draw a line down here, 3 times 8. If I counted all of them, I know 8 times 3 is 24. Because I memorized my facts. All right, and then 60 plus 24 is 84. So n equals 84. Or in other words, 3 times 28 equals 84. So now, the next thing, your assignment, pay close attention to this because this is what our assignment is going to be today. I like to think about equations like a pan balance. Like both sides have to balance for the equation to be correct. You could have a 10 on this side and a 7 plus 3 on this side. You can also flip-flop them. But the value on both sides has to be equal in order for it to balance. So if we looked at this equation, we have 7 plus 3 on this side is the same as 6 plus 4 on that side, because that's a 10 and that's a 10. So 10 equals 10. So that is a true equation. Sometimes you need to make it balance. There's a missing value here. So 7 plus 3 is 10, and that is equivalent to 5 plus what? And that's the work you have to do. So when it looks like this, a lot of times you have to actually solve this side. And then now we know that this side has to add up to that 10. So essentially, as a subtraction problem, 10, because we know the big number, 10 minus 5 is its twin, 5. Okay? And these problems can get even more complicated. They can be as complicated as your teacher wants them to be. So 9 times 5 on this side, well, if I solve that, I know it's 45. And the next side, 45 divided by what equals 45? Well, what goes into 45? 45 times? 1 does. Okay. So 45 divided by 1 is the same as 9 times 45, or 9 times 5. Sorry. Okay, so we'll do one last one. This side says 12 divided by 4 is the same as 18 minus what? Well, let's solve it. 12 cut into 4 equal parts, or 4 goes into 12 3 times on this side. So we need to make this side equal 3. So 18 minus what equals 3. Well, if we do 18 minus what equals 3, well, I also know my fact family. If I wanted to draw another subtraction problem that's in that fact family, we would flip-flop the missing value with the 3. 18 minus 3, well, that's easy. It's 15. So the answer to this problem isn't 3, it's actually the missing value, 15. Same thing up here. We found out that this value is 45, and we had to make this value 45. So the answer was actually 1 for this problem when we fill in the blank and we make them match. So that's how these work. I always think about it like a pan balance. You want both sides to be equal, and you can always they can be written like this, where you have just a number by itself equals, and then the work, the problem that you're doing, or it could be written like the more traditional way. They can flip-flop across the equal sign as long as you're reading them left to right. So that's that for today. Remember to rewind, come back and check this out if you get confused. If you're wondering how to do a problem, these videos are your friend. Thanks for watching and have a great day. Good luck.